Hey everyone, and welcome. Today, we're going to dive into one of the coolest ideas in all of AI, vector embeddings. It's all about how AI is learning to grasp what we really mean, not just the words we type. All right, so let's kick things off with a little puzzle. How does a computer figure out that a puppy is to a dog and a kitten is to a cat are basically saying the same kind of thing? You and I, we see that offspring to parent connection instantly, right? It's obvious. But to a computer? Those are just, totally different strings of text. So how in the world does it get that deeper relationship? Well, the secret, and this is pretty cool, is to stop treating words like, well, words. Instead, think of them like places on a map. Yeah, a map of meaning, where ideas that are like our neighbors living right next door, and concepts that are totally different are like on opposite sides of the country. So to build this map, we need some specific tools in our toolkit. And that's what we're jumping into right now, the core idea behind it all. We're talking vectors, space, and similarity. Okay, first up, the vector. And hey, don't let the fancy name scare you off. It's really just a bunch of numbers. Think of it like a GPS coordinate, an address. It lets us take anything, a word, a whole sentence, even a picture, and stick a pin for it on our map. Simple as that. Okay, so once we've got everything plotted on this giant map of meaning, the main rule is actually super simple. It all boils down to one thing: distance. Seriously, if two things are close together on the map, they're similar. If they're far apart, they're not. That's the whole game. And, because this is computers we're talking about, there's got to be some math to measure all this. It's usually done with a tool called Cosine Similarity, which honestly is just a super fancy way of asking, are these 2 points pointing in basically the same direction? If they are, they're similar. If they're pointing in totally different directions, they're not. I know, that might still sound a little out there. So let's bring it back down to earth with a really simple hands-on example. We're literally going to plot some people on a map, just like their data points. All right, check this out. Here's our map. Super simple, just 2 dimensions, like a piece of graph paper. So the line going side to side, the x-axis, that's going to be for gender. We'll put male on the left, female on the right. And the up and down line, the y-axis, that's for age. Under 18 is down low, and over 18 is up high. Okay, map's ready. Let's meet our test subjects. We've got 5 different people, and we know their age and gender. What we're going to do is turn each person into a coordinate, a vector, and stick a pin for them on our map. And there you have it. Once we actually plot them, look at what happens. It's pretty cool. The 10-year-old boy and the 2-year-old boy, see how they're basically right next to each other? They're clustered together. But then you've got the 80-year-old woman, and she's way over in a completely different corner of the map. Closeness means similarity. It actually works. So, okay, we've built this little map. What's the point? What can we actually do with it? Well, this is where things get really powerful. This is the idea behind something called vector search. Let's try to use our map to answer a question, to find the closest match. Okay, so here's our search query. We want to find the person who's most like a 17-year-old boy from the people we already have on our map. How would a computer figure this out? The process is actually really simple. It's just 3 steps. First, the system takes our search, a 17-year-old boy, and turns that into a brand new coordinate. Second, it plops that new point right onto our map. And last, it just gets out a virtual ruler and measures the distance from our new point to every other point that's already there. So the computer crunches the numbers for all the distances, and it finds a winner. The closest point on the map to our 17-year-old boy is P1, the 10-year-old boy. Makes sense, right? This right here is the core idea behind how modern semantic search engines work. It's all about finding the nearest neighbor. Okay, so our little 2D map with people is a great way to understand the basics, but let's be real, it's pretty simple. The real magic, the mind-blowing stuff, happens when we take this same idea and scale it way, way up to handle the massive complexity of human language. And that is the leap into what we think of as real AI. So what's the tech that lets us make this huge jump? It's something called sentence transformers. These are incredibly powerful AI models, and they're trained to do one thing really, really well. They read a sentence, figure out its deep, true meaning, its semantic meaning, and turn it into one of those high-dimensional vectors we talked about. And that final vector, that's what we call an embedding. And this is where the scale just completely explodes. It's kind of hard to even imagine. Think about it. We went from our simple little map with just 2 dimensions, age and gender, to a ginormous, mind-bending space that has hundreds or even thousands of dimensions. And each of these dimensions represents some abstract concept, like the tone of the sentence, or the author's intent, or the relationships between ideas. The power you get from this is just huge. You see, unlike old-school keyword search, these models aren't just looking for words. They get the entire sentence. They understand context. They get all the subtle shades of meaning. And then they wrap all that understanding up into a single tidy little vector that we can put on that crazy multidimensional map. So let's circle all the way back to that puzzle we started with. A sentence transformer doesn't just see a jumble of different words. It actually understands the relationship in each sentence, that offspring to parent idea. And because it sees that the underlying meaning is the same, it creates vectors for those two sentences that end up being super, super close to each other on the map. The machine, it finally gets it. And that really leaves us with a big final thought to chew on. I mean, this technology is already the engine behind smarter search results, chatbots that actually understand you, and recommendation systems that feel like they can read your mind. But just think, as machines get even better at mapping out this universe of human meaning, what's next? What new doors is this going to open? What's the next frontier?